This video covers section 3.3, quadratic functions and their properties. I will be taking the examples from the book. I don't think you necessarily have to have your book for the notes, but you might want to get it out. So we are going to talk about completing the square. We're going to talk about opposite of b over 2a. We're going to review h and k, increasing, decreasing. We're going to hit it all. So the first thing I'm going to look at is the f of x equals x squared minus 6x minus 1. And I want to find all of the pertinent information. I want to know the x-intercepts, or x-intercept depending, the y-intercept. I want to know the vertex, which is not probably, it is the most important point on the graph. I want to find the domain. I want to find the range. I want to find increasing, decreasing. This is a parabola. It has no constants. So this is what we're going to look at. Okay, so two ways to do the problem. The first way is the opposite of b over 2a. I know that you probably like to say negative b over 2a, but the x-coordinate of the vertex opposite of b over 2a. So in this case, that's going to be 6 over 2, which is 3. That also tells you the axis of symmetry. The axis of symmetry always slices right through the vertex. I will draw that in when I get to the graphing part. So if the x-coordinate is 3, the f of 3, which is going to be 3 squared minus 6 times 3 minus 1. So that's 9 minus 18 minus 1, which I believe is negative 10. So the vertex of this parabola is 3, negative 10. A is 1. Therefore, there's no reflection. If A was negative, then we would say it's a reflection over the x-axis. And because A is 1, there is also no stretch or compress. Y-intercept is pretty basic. You want to find the y-intercept of any function for as long as you are in a math class. The y-intercept is always plugging in 0 for x, and in this case, if you plug in 0 for x, you get negative 1. The x-intercepts, we're going to make y 0. So to find the x-intercepts, there's going to be 2 in this case. I'm going to make y 0. So 0 equals x squared minus 6x minus 1. It's not factorable, so I'm going to use the quadratic formula. It's going to be 6 plus or minus the square root of negative 6 squared. B squared minus 4, A is 1, C is negative 1, all over 2A. You don't have to show every single step like I just did. You don't have to show every single step. So this is going to be 6 plus or minus the square root of 36 plus 4, which is 40. All over 2. Always simplify radicals. Always. Don't just do this like whole crossing off of the 6 and the 2. It's voodoo math. So this is 6 plus or minus the square root of 40, which is 2 root 10 over 2. Now you can reduce. So you get 3 plus or minus the square root of 10 comma 0, and those are your x-intercepts. If you want to write them separate as 3 plus root 10, comma 0 and 3 minus root 10, comma 0, feel free. All right, let's put it all together. So I know that my the y coordinate of my vertex goes down to -10, so I'm going to change my increments on the y-axis. I'm going to leave my increments on the x-axis alone. I'm going to change the increments on the y-axis. I could do both. I would have you vote. You know what? Let's just be consistent. Let's just change the increments for all of it. So I'm going to go by 2s. Do not label every increment. 2, 4, 6, 8, 10. All you need, if you're changing your increments, totally allowed. All you need is to label one increment somewhere along the axis. Okay, so I'm going to start with my vertex. So the vertex, we determined, I didn't write it down, did I? Oh, I did, it's right here. The vertex, 3, -10. So 3, -10 is here. The y-intercept was 0, -1. So remember, I'm going by 2, so it's partially through. Oh, I can do a reflected point. I can do a reflected point. So the axis of symmetry is always a vertical line that cuts through. It always slices right through the vertex. So I'm going to draw it in. You don't have to, but I'm going to draw it in just so you guys can kind of see. Everything on a parabola is a reflection over this axis of symmetry. So if I know that the y-intercept is at 0, -1, so that means that my reflected point, let's see, 3 is at 6, -1, 2, 4, 6. How did I get that? This point right here is 3, -10. From the axis of symmetry to the y-intercept is 3, like, quote unquote, spaces, 3 increments. So if it's 3 from the axis of symmetry to the y-intercept, then in the other direction, I would have to move 3. So 3 left, 3 right. This point is a total of 6. Okay, 3 plus or minus root 10, and this is going to be the worst drawing ever. So root 10 is 3-ish. So these are exact, but I can't graph it exactly on paper. So square root of 10 is 3-ish. So this is 3 plus 3-ish. So this is a little bit more than 6. 3 minus 3-ish. This is a little bit less than 0. So a little bit more than 6 and a little bit less than 0. Okay, so 2, 4, 6, it makes sense. Kind of flows. This is going to be the worst drawing known to man. And ish. I do not take off points for your drawings, but oh my goodness. I'm embarrassed. This is going to be recorded for all to see. Oh. Not even close. Not even close. All right, where is the graph increasing and where is it decreasing? So the vertex is by far the most important point. So the graph is going to be decreasing. So from -infinity, I'm on this, technically the parabola is up here somewhere, we just don't have it drawn. So -infinity, so here's my x value. I'm sliding down this parabola until I get to an x value of 3. And then I'm sliding up the parabola, so I'm increasing beginning at the x value of 3 until infinity. So this is decreasing from negative infinity to the vertex, which is 3, parenthesis because it's a turning point. And then this graph is increasing from 3, which is the turning point, to infinity. All right, let's review completing the square and let's do some fractions. If you're interested, this is number 32, and I don't think the graph is going to be much prettier. Okay. This is going to be number 32, and I'm going to answer the same questions. And you know what? I did not do domain and range of the previous problem. Let's go back. I did not do domain and range. Sorry about that. Okay, domain. All real numbers or negative infinity to infinity. This graph is going right and left, both directions. You can also look at the equation. Are there restrictions on x? Are there any values of x that are not allowed? Okay, well, unless there's a denominator or there's a log or there's a root function, radicals, roots, fractions, problems. None of that here. The range, let's look at the vertex, most important point on the graph. So the range here is going to be -10, which is included, to infinity. The lowest y value is -10, close circle. Okay, so sorry about that. Let's go look at number 32, which has a lot of fractions in it. And I'm going to review how to complete the square with fractions because I know that is by far your most favorite kind of problem to do. Two-thirds x squared plus 4/3 x minus 1. So same thing, I'm going to find the vertex, the x-intercepts, y-intercepts, domain, range, increasing, decreasing. So you can use opposite of b over 2a. I probably would, except that I want to review how to complete the square and write in vertex form. Okay, so I'm going to change the f of x to y in a minute. I want to move c to the other side. Okay, so I just took f of x, made it y. I moved the -1 to the other side by adding 1. When you complete the square, a must be 1. When you complete the square, a must be 1. Well, a is not 1. A is 2/3. So out it comes. That leaves you with x squared plus x squared plus what? Well, 2/3 times x squared is 2/3 x squared. 2/3 times something needs to get me 4/3. Well, that something is 2. 2/3 times 2, I believe, is 4/3. All right, and now we need to find c. So now we need to complete the square. b is now 2. So you're going to take half of b and square it. In this particular problem, b is 2. Over 2 is 1. Squared is 1. If you need more help with completing the square, if this is going too fast for you, come to office hours. Don't forget to make an appointment. We've been completing the square for a long time. So here comes the +1. Oh, but not really. I added 1 to the right. So I need to add 1 to the left. Nope, that is not true. I did not add 1 to the right. Remember I said, okay, 2/3 times x squared is 2/3 x squared. Perfect. 2/3 times 2x is 4/3 x. Perfect. 2/3 times 1 is 2/3. So rather than adding 1, I really added 2/3 times 1. And if I add it to the right, I must add it to the left. You can go back and watch the video on your own and pause it for yourself. So 1 plus 2/3 is 5/3. Factor, and you get 2/3 x. What did you square to get 1? You squared 1. So I factored it. The whole point of completing the square is that you have created a perfect square trinomial. Whatever you've got here, this x squared plus 2x plus 1, whatever problem it is you're doing, this trinomial must factor perfectly. That is the point of completing the square. You can leave it this way. Generally, you're going to see the k on the other side. That's a 5/3. It's a little messy, and I'm not using erasable pen, so I can't adjust it. Sorry about that. Okay, vertex is going to be at -1, -5/3. What value of x makes this quantity 0? -1. And if x is -1, you get 0 squared is 0 times -2/3 is 0, and you're left with -5/3. Y-intercept, go back to the original problem. The y-intercept is going to be 0, -1. You want to find the y-intercept of any function, you make x 0. So you just plug it straight in. Okay, so the x-intercepts, the domain, the range, the increasing, the decreasing. Okay, this vertex is going to become critical for our analysis of those items. 2/3, no reflection, but the absolute value of a is less than 1. A is 2/3. The absolute value of a is less than 1. 2/3 is less than 1. So therefore, this is a stretch. From the y-axis. Okay, I'm avoiding the x-intercepts, but let's just go for it. We can do the quadratic formula. I'm not super keen on the quadratic formula right now. We can try and set y equal to 0 here. Boy, I don't think either one of these is going to be pretty. I have a feeling that if you could vote, you would tell me to do the quadratic formula. I think that's what you would tell me to do. So guess what? That's what I'm going to do. Okay. I have a great idea. When you're doing this on your own, you should push pause and see how you do. Okay. Opposite of b, plus or minus the square root of b, which is 4/3, squared, minus 4. A is 2/3. C is -1. All over 2a. If I could pause the recording, I would do it here. Let's hope I don't mess this up. So this is going to be -4/3 plus or minus the square root of 16/9 plus 8/3 all over 4/3. No crossing off of these 4/3. Okay, -4/3 plus or minus the square root of 16 nines, that's times 3, 24 plus 16, 40, I think. Sixteen nines plus 8/3, I believe, is 49 times 3 is 24. That's 4. Okay. Well, this is now -4/3 plus or minus the square root of 40 over 3 all over 4/3. Square root of 49, square root the numerator, square root the denominator. Well, this is fantabulous. They all divide by 3. Your complex fraction days. So this becomes -4 plus or minus 40 is 2 root 10 all over 4. The 3's reduce out because it's a complex fraction. 40's, yep. And then divide everything by 2 and you get -2 plus or minus the square root of 10 all over 2 comma 0. Bing bang. Wow. How do you like them apples? Looking at the answer, it may have been easier to do it the other way. It may have been easier to do it the other way, meaning going from here and setting it equal to 0. Now, it absolutely would have been easier to do it that way. Maybe I'll do that part in another video. All right, here we go. So now we can graph it. Now we can graph it. What's my, okay, I'm going to go by ones. I'm going to try and squeeze it on here. All of your graphs need to be drawn on a separate axis. All of your graphs need to be drawn on a separate axis. I'm going by ones. You do not need to label anything if you are going by ones. Okay, vertex, -1, -5/3, -1, 3, -5/3-ish. The y-intercept was 0, -1. Reflected over the axis of symmetry. There you go. Okay, so -2 plus or minus root 10. So again, root 10 is about 3. So this is going to be -2 plus or minus, I'm going to say 3.1 just for the sake of trying to find the value. This is purely just to get a rough estimate of where it is. So this is going to be 1.1 divided by 2 is 0.55-ish. And -5.1 divided by 2 is like -2.5-ish. So half and 1, 2. This was just me playing around with the numbers in my head. Domain, all real numbers. The range, look at your vertex. The vertex was -1, -5/3. So the range is bracket -5/3 infinity. It is decreasing from negative infinity to -1. And then it is increasing from -1 to infinity. Remember, these are not points on the graph. These are intervals on X. This is an interval. They are not points on the graph. Okay, I am going to do one more. It's going to be a word problem. One more, and it's going to be a word problem. Parabolas exist in the real world often. We'll see a lot of businesses use like cost benefit, and not a cost benefit analysis. Sorry, that's the wrong thing. You're looking at revenue versus how many items you sell versus how much it costs to make the item. So I'm going to look at number 86. You want to maximize your revenue. You always want to maximize your revenue, and you always want to minimize your cost. Always. You want to maximize your revenue. Which means you're going to look at, for sure, an upside down parabola. Like this is the point you want. And you always want to minimize cost. So when you're doing that, it's going to look something like a right side up parabola. You'll learn more about this in econ, but this is just a generic parabola. So maximizing revenue says the John Deere company has found that the revenue in dollars from the sales of riding mowers is a function of the unit price P in dollars that it charges. Okay, so R is equal to the revenue. Of the price P. Okay, and the function they give you is the revenue as a function of price is equal to -1/2. There's your negative, upside down parabola. -1/2 P squared plus 1900 P. I'm going to be honest, I think a lot of times the word problems take less work, in this book at least. The word problems take less work than some of the, 1 to 11 odd type problems. So don't be turned off just because it's a word problem. What unit price should be charged to maximize the revenue? What is the maximum revenue? Okay, so the price is a function of revenue. So it's like saying here, your f of x. So I'm looking to maximize I'm looking to maximize revenue based on this price. Well, P would be the equivalent of X. This right here, vertex, doesn't involve finding X. The X value is the equivalent of the P value. I need to find the vertex. Don't complete the square. I'm not going to lie, I rarely, if ever, complete the square, but I thought it was important to review it. Okay, I would use my calculator actually for this one as well. So that's going to be -1900 over 2a, that's -1. Bing, there you go, problem done. Problem done. Oh, not totally. What is the maximum revenue? So if they charge $1,900. Is it a lawnmower? A riding mower. If they charge $1,900 per riding mower, the revenue will be, yes, you should write out a sentence. If they charge $1,900 per riding mower, the revenue will be, well, what's the R? of 1900. Negative 1/2 1900 squared plus 1900 times 1900. Isn't that just 1/2? 1900 squared. Okay, so I cheated. I already did the problem. $1,805,000. Charge 1900, you'll get a max revenue of 1,805,000.